Scientific notation. Scientific notation is used to simplify reading, writing and calculating very large and very small numbers. A number in scientific notation is expressed as n times 10 to the power of k, where n is 1 to 10, including 1 but not 10. So 1 or more but less than 10, and k is any integer, so it can be positive, negative or even 0. Multiplying number by 10 to a negative exponent will shift the decimal to the left. So 3.87 times 10 to the negative 4. If I want to get rid of 10 to the negative 4, I'll have to move my decimal 4 places to the left, giving me 0.000387. Multiplying a number by 10 to a positive exponent will shift the decimal to the right. 4.56 times 10 to the 4, I'll move my decimal 4 places to the right, end up giving me 45,600. 45600. I move it 4 decimal. I only have 2 places, so I include extra zeros at the end. In short, whenever we have a negative exponent, we will get 0.00 something as the answer. When we have a positive exponent, we will have a bunch of zeros at the end. So negative exponent number will be very small, 0.00000 something. Positive exponent will have large number, 100, 1000, 10,000, million, billion and so on. Okay, let's practice some of them. Write the following numbers in scientific notation. So 74 followed by 4 zeros, we can write it like 74. Again, we have 74 followed by 4 zeros. We have to move decimal place such a way that we end up with a number between 1 to 10 and the exponent can be any number. So if I have no decimal, I assume it is at the end. Move it 1 place, 2 places, 3 places, 4. How do I know where to stop? We need to stop where we hit a number between 1 to 10. So if I move it 4 places, I am only at 74. It's not between 1 to 10. So one more will take me to 7.4 times 10 to the power of 5. Okay. Next one then we have 0.9. So moving 1 decimal place to the right. Again, why to the right? Because we need a number between 1 to 10. 0.9 is not between 1 to 10. So if I move it 1 to the right, we will get 9 times 10 to the exponent negative 1. Now, how do I know if I need positive exponent or negative? I get positive or negative exponent. If you're moving your decimal to the left, it will be a positive exponent. If you're moving your decimal to the right, it will be a negative exponent. Another way to know it is, if it's a large number, more than 10, it will be a positive exponent. A number lower than 1 will be a negative exponent. So 200, I know I'll get a positive exponent. There is no decimal at the end, so you move it 2 decimal. Again, how do I know 2 decimal? Because if you move 1 decimal, you get 20. It's not between 1 to 10. So one more will give us 2 times 10 to the power of 2 or 2 times 10 squared. For D then, moving it 1, 2, 3, 4, 5, 6 places. How do I know to stop there? Because I get now 5.03, which is between 1 to 10 times 10. Again, because it's a negative, it's a 0.000, I will get a negative exponent, and in our case, to the negative 6. Now 2. Again, it has no decimal. 2 is already between 1 to 10. So to express 2 as scientific, as a scientific notation, we get 2 times 10 to the power of, because I did not move it any decimal, it will be 10 to the power of 0. Okay? Because 10 to the anything to the exponent 0 is 1. So 10 to the power of 0 is 1. 2 times 1 will be back to 2. Now, how about going backwards? These numbers are given to us in scientific notation. Putting it into standard notation, also known as ordinary notation or decimal notation, we move our decimal places. It's positive, move it to the right. Negative exponent moving to the left. So it's backwards. In other words, if I have positive exponent, I'll get a large number. If I have a negative exponent, my number will be 0 point something. Okay? So for this one now, moving it 6 decimal places, I'll have 24 followed by 5 zeros. Okay? Because if I moved 1 decimal, I get 24. But I need to move it 5 more decimals. So I have to include 5 more zeros. For this one now, moving it 4 to the left, I moved 1. I get 0.641. But I need to move 3 more places. So what I'll end up doing is, I'll have 4 zeros in front, but there will be a decimal after the first 0. How do I know 4 zeros? Because of the 4 here. So it will be 0.1230641. If you were to double check your answer, if you try to put this back into scientific notation, you move 1 decimal, 2, 3, and 4. And you get 6.41 times 10 to the negative 4. Similarly, 9 times 10 square. 10 square means move your decimal 2 places to the right. There is no decimal, so it's assumed after 9. So 900 will be your answer. And for D then, 3 times 10 to the negative 1 will give us, moving it to the, move decimal to the left will give us 0.3. Okay. Now for this one, we'll need a calculator. So we take 3.4, we punch in calculator 3.4 times 10 to the 15, subtract 1.7 times 10 to the 12. Some of us can do it without calculator, some of us will need calculator. If you punch this in calculator, your calculator should give you something like this. 3.3983 times 10 to the power of 15. Now, for this number in particular, because we are subtracting numbers, as we saw rounding rules, when we add or subtract, we look at lowest number of decimal in the question. When we do that, these numbers 10 to the power of something are not counted. So 3.4, 1 decimal after the number. 1.7, 1 number after the decimal. So if you were to round according to rounding rules, our answer should have been 3.4 because we only want answer with 1 decimal. So it will be 3.4 times 10 to the power of 15. Okay. So it's back to this number. Then what did we subtract? Because the number we subtracted is comparatively very small to this number, it turns out to be that it's not going to impact your answer when you use rounding rules. Similarly, use your calculator to punch this in. If you use your calculator, make sure you put extra bracket in the denominator right here. Otherwise, your calculator will divide this with this part and it will start to multiply this right here up, which is wrong. So we will have to put extra bracket here and extra bracket here in the calculator. When we do that, our calculator should give us answer to look like this, equals 3.204 times 10 to the power of negative 10. However, again, rounding rules, this has 3 significant digits, this has 3 significant digits, this has 3 significant digits. Why do I look at significant digits? Because we are multiplying and dividing. So the answer should be 3 significant digits. This number in 3 significant digit will be 3.20 times 10 to the power of negative 10. Now for this particular question, we were asked to round to 2 decimals. This also satisfied that condition. This number right here is with 2 decimal. If we were not given this, if we are given round to particular way, we have to follow that. So in this case, it would be, without looking at significant digit, it would have been 3.20. But if it does not say this, if we are not given that, then I have to round according to 3 significant digit, which will also turn out to be same number.